All right, before we get started, I figured I would point out, if you don't have one of these, we're giving away an Apple iPad. You can fill out one of those. They're sitting around on the chairs. So, feel free to fill out as many as you'd like. Well, good morning, everyone. My name is Brian Garrett. I'm with Sas, and I'm here to talk to you today about open source and Sas and why people still use Sas. Quick show of hands in the room. How many of you are Sas users today? Okay, reasonable number. Thank you. How many of you have even heard of Sas before? Okay. Anyone not? Okay, perfect. All right. It's only the Sas employees in the back that are raising their hand. Perfect. Okay, well, let's go ahead and get started. I wanted to spend a couple of minutes talking about why Sas. And, from my perspective, Sas comes from really four sort of key pieces on, at least with respect to the open source community. One of those is the concept of experience and expertise. One of them is about the value that Sas brings to organizations, one being the innovation that Sas brings to the marketplace, and finally, the concept of leadership. So when we talk about expertise and experience, a couple of things just to keep in mind about Sas. We were founded in 1976. We have about 13,500 employees worldwide. Across about 400 different offices. And we are actually the world's largest privately held software company. Now, one of the interesting things about Sas is that we, on an annual basis, put back about 25% of our revenue into R&D. And that's huge for a software company. But it's something that we believe is critical to driving innovation and leadership in this space. Employees for us are probably one of the biggest assets in our company. To give you a feel, on average, people have been at Sas about 10 years, is about the average tenure. And we have more than 450 people who have worked at Sas for more than 25 years. And so when people come to Sas, they generally stay. And that's important for a variety of reasons. It's nice to have the developer that authored the code 10 years ago still being down the hall from you. And we can't underestimate the value of that intellectual property that's locked up here in people's heads. And so as a result, we have one of the lowest turnovers in the industry. We average about 3% these days. It's actually gone up a little because we have some people who are beginning to retire. But the industry average is about 22%. So if you think about a 22% company, you're talking about a full turnover in about every 4 to 5 years. In our case, we're at about a full turnover about every 30 or so years. And so as a result, we have managed to keep, to attract and retain some of the best and brightest analytical talents in the company. One other thing from an expertise perspective, to give you a feel, when we talk about our statistical work that we do, about 85% of our statistical products development and testing teams have advanced degrees, and over half of those have PhDs in either math, stats, or operations research. Our Advanced Analytics Lab is a specialty group that we put together a number of years ago to tackle some of the newest emerging technologies and analytical expertise. 98% of them have an advanced degree, and about a third of them have PhDs. And so as a result, we end up with a lot of skills, both academically, but also from an experience perspective. And it's important when you look at that development and testing that, when we talk about SAS, when we talk about writing algorithms, one of the things that's key for us is really the rigorous testing and algorithm validation that we do inside our products. And so, that's really the only way that we feel that we can be reliable, that we can be proven for enterprise use, and be the most accurate in the industry from a testing perspective. Now, a couple of things just to give you a feel for our customer base. We have about 70,000 sites worldwide that actually use SAS. And we're in about 90 of the top 100 Fortune Global 500. And revenue-wise, we generate about a quarter of our revenue from the banking segment, but then also from really all the other major segments. And that's really important from us because really we leverage a lot of our customer input into building the products and building the solutions that we offer. And so I just point that out from a perspective that we're really in all the major industries. And really because of that, we've gone about to build really extensive training, documentation, and solutions for really all of our product sets. Now, when we talk about SAS, SAS is more than just a single product. And for those of you who are new to SAS, that might come as a surprise. How many of you used SAS when you were in school, graduate school, undergrad, high schoolers now are using it? But okay, all right. So certainly we have sort of at our core the concept of analytics. And really that's one of our several pieces, but we also do a lot of work with data management, with data quality, with data lineage, data governance, a lot with master data management, a lot with everything from complex event stream processing right through data quality, through data management, through a whole set of business intelligence tools. And for us, it's not just about the proc or data step that you wrote once. It's about this entire ecosystem. And so to give you a feel, I went ahead and listed a subset of our products up on the screen just to kind of give you a feel for the depth and breadth, because it's a lot more than just products. We do a lot of solutions. We do solutions for things like fraud and credit risk. And we do solutions for merchandising and solutions for customer intelligence. And so it's a very large variety of products that actually all rely on the same core technology underneath. It's the same algorithms, the same statistical methods, but what we've done is we've built all of these different products in very specific ways. So with that, when we start talking with customers about our technology, and we really look at this as kind of a circle, because although many of you, you're here at a Hadoop conference, and Hadoop is all about the persistence of data in a relatively cheap fashion, and the concept for distributed storage, but also the concept for distributed processing. And from our perspective, we care about that, but we care about it in the context of what it can tell you, what you can do with it, what answers it can give to you. And so for us, we look at these things from a life cycle perspective. And so, if you start at kind of the top of that particular diagram, where we pick out what the particular problem is. We'll then go through a data prep phase, and that might be data quality, it might be data lineage, it might be data governance, it might be the ETL or the ELT jobs that you're used to running. It might be data cleansing of some sort. And then, what we find is that kind of swings around. We find that people ultimately want to play with that data. They want to look at it, they want to explore it. And so for us, we've built our careers on the fact that we can offer things all around this wheel, whether it is the data prep, the data exploration, the data modeling down around the bottom, even the data validation and the maintenance of those particular models, the care and feeding and life cycle of those models, and then around to even doing scoring. Because for those of you, how many statisticians do I have in the room, or data scientists in the room? Okay, they all sat on that side of the room. All right, perfect. It was probably the most efficient because it was closest to the lunch. Perfect. And so for the data scientists in the room and the data modelers, you know that modeling is only part of the solution here. The second half of this is really the concept of scoring. Now that I have a model, what am I going to do with it? How can I gain value from it? And so if you're getting to the point that you're trying to do a lifetime validation, a lifetime customer value for all of your customers, and you build a new predictor for it and you want to run that, or you have a new model that will detect fraud and you want to run that against your entire population, scoring is a very different problem than the actual building of the model. And so for us, that's really what derives value in this sort of circle for us. Does that make sense? Perfect. All right. So I promised you a discussion today. If you read the description and the write-up of this, I wanted to also talk about how we are integrating with open source and the open source community. Now, from our perspective, the open source community brings a tremendous amount of value. It brings a lot of people from very disparate backgrounds and experiences all coming together to solve a problem. And we believe that there's a lot of really good work, collaborative work in the open source community to actually get together and come up with new problems and new ways to solve them. And so to that end, we've opened up chunks of our software to allow it to integrate with certain things. For example, our IML product, which is our matrix manipulation product, allows us to actually submit our code within SAS. So you can be running our tool, IML Studio, and you can get down and want to do some matrix manipulation and want to do some functions within R, and you can do that. And so, as a result of that, what you find is code blocks like this. Everything between the two sets of arrows, for example, is actually our code that's actually submitted inside this particular code. And so for us, it's about enabling the technologies, the things that it's good at, to allow you to be able to play with it. Now, it goes a lot just beyond IML Studio. One of our flagship products is actually our enterprise miner product, our data mining product. And one of the things that we're very excited to talk about and announced is really how you can take open source integration and tie that inside your enterprise miner model. Now, enterprise miner, for those of you who may not know, is a drag and drop interface that allows people to do data mining. Okay? And so one of the things that we have on here is you can see kind of the process flow. A modeler would simply drag and drop the particular blocks and connect them together to get a process flow out of it. And so in this particular case, what we're actually showing is a split of data and then going out to two different technologies. One, our part with PMML, and one, our SAS decision tree. And the real value of that is really the ability to go create ensemble models, to be able to take those particular models, pull them together, and then see if you can make a better model as a result of it. And so we will actually allow you to integrate that, and you can actually see, in some cases, we'll find ensemble model improvements specifically because we've incorporated other models. Okay? So from an enterprise miner perspective, we're actually going to allow you to pull in any number of the major statistical modeling techniques that are in a technology like R to be able to pull that in and integrate that with that. We also offer the ability to actually integrate in those types of components as well as others. Now, I should point out that one of the nice things, because we have that big wagon wheel sort of thing, that analytical life cycle that we showed up earlier, is one of the things that we know how to do is data management. And so one of the very nice things from a data mining perspective is really being able to do some sort of cleaning. So for example, certain packages are not very good when they run into missing values. They're not very good with different data types or formats. And so one of the things that we see some of our customers do in this sort of case is clean up the data, adjust the data in some way before they pull that into particular models. And so a product like Sas can help with that data preparation within the product. Now, I'd be remiss if I didn't at least mention model deployment, that once you have the model that you want and now want to deploy that out, we have a number of technologies that actually do that, including scoring engines that can deploy in database, whether it's a traditional relational database or in Hadoop. And so we have products like our scoring accelerator that actually allow you to pull in that particular model, build the parameters, build that equation that do that calculation, and then push it into Hadoop. So if you want to build your model and run in parallel, you can. So how many people have heard that Sas is expensive? Okay. We get that a lot. We do hear that. But when you really start talking about any type of software product, you really need to have the conversation about a total cost of ownership. And for us, when we talk about the analytic ecosystem that makes up this system that you're going to do analytics, it's a lot more than just the individual system. For example, the analytic ecosystem is made up of hardware, obviously, and software, and that's what we do. We do the software, obviously. But it also has human capital cost, and that human capital cost comes across not only from a line of business perspective, but an IT perspective. Make sense? And so all of these really go into that. Now, if we look at kind of an evolution here, and let me walk you through this particular slide. If we go kind of across an evolution of this, on the left-hand side of your screen, going to the right, you'll see really kind of a typical evolution. You'll see that, if you're using legacy platforms in some sort of warehouse, you've got some amount of a cost of ownership for that. Now, we can debate whether or not we're a little high or a little low on these, but in general, this should make sense to you. We find that as people move into some sort of grid computing, we have lots of different solutions. We have a grid computing solution, but there's plenty of others on the market too. We find that those numbers begin to shrink. They shrink from a hardware cost, although they keep most of the other technologies, most of the other sizes approximately the same. As we move over to using some sort of grid computing with Hadoop primarily as a storage mechanism, how many of you today are using Hadoop? Okay, That's fine. It is a Hadoop conference. I would expect some hands. How many of you are mostly using it today for storage? A few of you. Okay. All right. And so we find that we do continue to bend that curve a little, even at the lower cost of storage. What we hear from customers is that the cost to persist data in Hadoop is about $1,000 a terabyte or so. And that's much better than other technologies, whether it be SANs, whether it be appliances, that sort of thing. And as we move into Grid plus Hadoop for using some computations in that curve bends again. And what we've found is that we believe that the direction of analytics is really going in the direction of in-memory. And when we talk about in-memory for us, we talk about in-memory in a distributed fashion, not simply in-memory of one machine, but in-memory across all of your machines. Maybe it's tens, maybe it's hundreds of nodes that are actually distributing this data in memory across all of these particular technologies. And so for things like that, we find that the curve drops again, and we see this type of curve across the adoption for technology. Make sense so far? Okay. Now, if I overlay open source into this, what I often hear is, gee, we can do it cheaper, okay? We can do it cheaper from a platform. We can do it cheaper all along because we can go build our own. We can go get an open source distribution and pull it in on our own. We can license this technology more cheaply. We can get a free copy. We can do that sort of stuff. But the interesting thing about that is that these curves often are hiding a set of numbers. They're hiding the increase in human capital, okay? And so from a human capital perspective, what we find is that those numbers are actually growing, that you have teams of people who are writing MapReduce. You have teams of people who are having to do the care and feeding of these systems. And so what we find as we begin to look at it is that the curve is a little bit higher, okay? And so as you get into more and more stuff, I talked with a gentleman this morning that had been rolling his own Hadoop distribution for 5 years. He's been doing Hadoop distributions for 5 years. He came and talked to me this morning at our booth. And he and his team have written all of their code, right? They need a new feature. They have to write new code. And so, it's important here to really understand that there's a gap here in this. And so one of the things to keep in mind here as you move forward into these distributions is that there's often this gap that is a hidden cost because it's hidden inside your line of business users, or it's hidden inside your IT groups in terms of an overall total cost of ownership. Now, with that, and thankfully no one has stormed out of the room yet, I do want to actually talk about some of our analytical innovations that we're actually putting forth in Hadoop today. How many of you have heard about our high-performance analytics? Okay. For us, we ran into a case about 5 or 6 years ago where we had a customer who was building risk models, and those risk models were taking longer and longer to run, and they were needing to do weekly models, but they were approaching their time window to be able to do it. And so when we went back and looked, they asked if we could come in and look at how to address it, how to speed that up. We began counting clock ticks, because at the end of the day, when you talk about analytics, you have to go through so many individual steps. And what we found is that the amount of data and the computational intensity was going to quickly outpace even Moore's law, okay? And so for that, what we did is we set about a process to take the algorithms that we've built and run them in parallel across a set of machines, okay? And so we started with appliance vendors. Okay, we started with the Teradatas of the world and went to them and said, hey, you've got all these boxes, you've got all these CPUs sitting here. Can we work together to try to build something that can run in a massively parallel fashion to actually do that calculation? And so we began doing work on that. And then over the past 5 years, as Hadoop became more and more popular, we looked and said, hey, wait, we've got this concept, this massively parallel concept of running algorithms. And if we've done the work to re-architect the algorithms, let's run them inside of Hadoop. Let's run them on the data nodes. Let's run them nearby the data nodes, but in a massively parallel fashion. And so what we did is we began re-architecting individual procedures, individual statistical procedures. And for us, those go across many different families, because you saw that there was a really big list of different products and solutions. But they fall into major categories. They fall into categories like statistics, like data mining, like econometrics, like text mining and forecasting. And so when we began looking at those particular algorithms and trying to decide how we could re-architect them, what we did is we began rewriting those. Now, not every algorithm is parallelizable, but we've taken about 30 to 35 of the top most frequently used ones in our, that we hear our customers talk about, and we've built those out to run in parallel. And so whether it's logistic regression or neural networks or decision trees, and you have millions or hundreds of millions of records that you're trying to walk through to do these sorts of calculations, we can actually we've actually re-architected those to run in memory in a distributed fashion. Now, it's not just about massively parallel systems. We did, by the way, use MPI, a message passing interface, for this technology, because a technology like MapReduce really is not optimized to take advantage of a known fixed algorithm that you're trying to run in parallel in a distributed way. Now, we also at the same time began looking and saying, okay, we want to do this type of playing with that data, but we wanted to do that at scale. You know, the BI tools of old, where you had a SQL generator and a mid-tier that hit a back-end relational database, that was fine if you had 1,000 records, if you had 10,000 records, even if you had, 500,000 records. But it began to fall over as you get into billions of records. And I've talked with a number of you guys today about the types of data volumes you are, and you're way beyond the hundreds of millions of records, many of you in the room. And so one of the things that we began to look at is, could we build an in-memory tool that would allow for data visualization, one of those spokes on that, on that wheel, going around? Could we enable data scientists to do that? Could we even allow programmers to actually do that? And so to that end, we began building and are proud to have released a number of these products this year. The first one is visual analytics, and visual analytics is a drag and drop tool that goes against millions, hundreds of millions, billions of records. If you come over to the booth, we'll show you 1 billion records dragging and dropping through this tool. And we get to that and we accomplish that by doing a distributed in-memory analytical store. Now, when I say distributed, I mean taking the data that you've splayed out across your HDFS, across all of your particular nodes, and enabling each of those particular machines to play their part to lift that data in parallel up into RAM. And maybe you do it directly on your Hadoop cluster, where you take some of the RAM off of each of your Hadoop nodes. Or maybe you build up a set of a rack of machines nearby that are more special purpose, kind of a math rack, if you will. And instead of lifting directly up into memory, you lift in parallel up into that particular math rack to be able to do the analysis that you want. So the technology that we're using here is a technology that we refer to as a laser server. That laser server is a in-memory distributed stateless system. It's very different than an in-memory database because you don't ask for rows and columns out of this. You ask for analysis. You ask for a forecast. You ask for a decision tree. You ask for a correlation matrix. And so that type of technology allows you to do that in a massively parallel fashion and return the results. Now that's great for a business user who wants to get from descriptive statistics to predictive statistics, right? But the data miners, the data modelers, the data scientists wanted and asked for more than that. And so whereas this meets some of the needs of the data manipulation, exploring, and even simple modeling, it probably doesn't go far enough for doing the type of modeling for a data scientist. The concept of being able to use this same pattern, of being able to lift this data once into RAM, and then turn you loose to be able to do classic modeling, classic statistics, or even machine learning types of algorithms in RAM in a distributed fashion is huge. And so, from our perspective, we put together an offering that we're actually showing at our booth, SAS Visual Statistics. Visual Statistics actually allows you to do everything from build models on the fly to play with the models, lasso things that you don't want in the model, exclude them, find outliers, look at those sorts of tools. If you're a statistician, or you have statisticians here, data miners, data scientists, we would encourage you to come by and take a look at this and see it work in real life. Because it's actually pretty cool, the ability to kind of build a model and then take a classification effect, drop it in, and have it blow out to hundreds of models without any extra code. It's a drag and drop tool. Finally, we also decided that some people didn't like GUIs. Inevitably, they wanted code to write. And so we've also opened up an interactive procedure that allows you to do these types of commands. So whether you're trying to do SVD, whether you're trying to do a recommender engine in memory across all of that particular data, either implicit or explicit, you can do that with this tool. Okay? And the good news is that all of this works together. This is all using the same in-memory concepts to lift the data up in RAM in parallel and then operate on them. Because the important thing about analytics is it's very different than a query. If all you're trying to do is run a SQL query against something, you really want a subset of rows to come back. And you may not even want all of your data nodes to be involved, which is why you guys are using partitioning strategies as you lay down data across HDFS. Because you don't want all the nodes to be involved in every problem. But if you talk about modeling, you have to do that very differently. Most modeling, most statistical models as it stands, really use large sequential block reads of a data. You take a data set, you take the biggest bite you can, and then you keep taking bites until you've eaten the whole cookie, right? You start at the beginning and work all the way down. And even more importantly, most of the time you have to go through that process and iterate and iterate and iterate. And so that's where the value of a tool like this comes into play. And so for us, this really meets sort of a much broader range across not only a business analyst, but into a statistician, into a data scientist. Now, I want to talk about leadership in analytics. How many of you have employees who have gotten out of college in the past 5 years? Okay, all right. One of the things that we announced in this spring at our SAS Global Forum is that we have begun to make SAS available for free to people who want to learn it. And that's huge. If you go to sas.com/university edition, you can go through a registration, download a VM to your machine, and you can learn to program in SAS. We have videos, we have training, we have documentation, we have technical support. It doesn't matter whether or not you are a student enrolled in a college or you just want to learn it yourself. You can go get a copy of SAS today and do it. And so this is really cool, in my opinion, because it allows you to actually pull in and play with the product to see what types of power you can get, to use data. Now, you can't use this in a production environment. I mean, there's some restrictions on that sort of thing. But to get it in, to download it, to get it running on your machine, you can do that, and you can do that today. Okay? I will point out that the SAS Studio product is actually the interface that we're using. It's a programming interface. It's got all the normal types of things you'd expect. Code completion. It's got the concept of writing code. You can use your own data sets. You can store data locally on your machine, not just on a virtual machine. That sort of stuff. So it's a real exciting prospect of being able to pull in and use this type of technology. So at this point, hopefully we've given you some idea of how really experience and expertise come to play in SAS, how we bring value into the analytics that your enterprises and organizations do, how we're innovating in the field, and how we're taking a leadership role in training the next generation of statistical and data science, statistical programmers and data scientists. So with that, please come see our booth. Come visit us on the web at sas.com/Hadoop Summit. And at this point, I will open it up to take questions. I'll direct you over there if you have any questions. Bill, can you walk towards the mic? Or you can give me the question while you walk to the mic, and I'll...
Yeah, my question is we talk about video stats, and all the calculation is in RAM. This RAM is SAS Freedom RAM, right? Not
Yeah. Okay, so let me repeat the question since I'm on the mic and you didn't make it to the microphone. So the question was, gee, you saw something about SAS visual statistics, you heard something about visual statistics, and what RAM is that when I talk about RAM and distributed RAM at that? In our case, both the in-memory statistics for Hadoop, the visual statistics, and the visual analytics, 3 different products, all use a back-end laser server, our SAS laser server product. That's really the technology behind it, and they're all using the same piece of technology there. That is a distributed in-memory analytical store, is what we talked about earlier. And you can deploy that a couple different ways. You can go put that on individual data nodes inside your Hadoop cluster. Commodity hardware, I have so much RAM in there, I'm going to use a little bit of RAM or a lot of RAM across a lot of different machines to, in total, be able to pull up terabytes of data. I've got the demo that we're doing in our booth is, I think we have about 3.2 terabytes lifted into RAM at the moment across about 60 machines or so. That's actually one of the sets of machines that we're connecting to. In that case, we can put that directly on the data nodes. Some people don't want that. They want that off segregated in some sort of way. And so we could put that in other machines across a set of machines and still get in parallel and lift the data in parallel rather than the pattern of lifting it up off of disk, off of HDFS blocks, up into RAM. But we can also lift it kind of in parallel up into kind of a math rack to do that. Does that answer your question? Perfect. Any other questions? Well, perfect. Okay, well, thank you very much.